So now, like in the previous class, we understood a bit about AP. Then some of n terms of AP. We have done 2 or 3 questions on AP, then geometric progression, then a question in GP. Then we have done more questions on GP, some of infinite terms of GP. Then there comes harmonic progression. The arithmetic geometric progression, we have totally derived how do we get the sum of an arithmetic geometric progression. Understood? Then we have done a question on AGP. Then I told you a bit about AMGM inequality. Now today, I will start with the very first question of AMGM inequality. Then we will go further for like more questions over the concepts. So see, the question is, A, B, C, D be positive real numbers such that A plus B plus C plus D is 11. All right. So given to me is A plus B plus C plus D is equals to 11. They're asking for the maximum value of this. Now see, since this is product of something, this has to be in the geometric mean side. Now here it is A to the power 5. So let's do one thing. Let us divide A into 5 equal parts. So A by 5 plus A by 5 plus A by 5 plus A by 5 plus A by 5. Then there is B cube. So divide B into 3 parts, B by 3 plus B by 3 plus B by 3. Then there is C square. Divide C into 2 parts and then D. So there are total 1, 2, 3, 11 quantity. So this whole divided by 11 is equals to, now product of all of them. So A to the power 5 upon 5 to the power 5, B cube upon 3 cube, C square upon 2 square into D whole to the power 1 by 11. So this is what I did. AM greater than or equal to GM. Got it? Now left side, if you realize, it is basically A plus B plus C plus D upon 11 more than or equal to. This is not equal to, more than equal to A to the power 5 upon 5 to the power 5, B cube upon 3 cube, C square upon 2 square into D whole to the power 1 by 11. Now this value is already 1 because A plus B plus C plus D is 11. So this value is 1. That means A to the power 5 B cube C square D upon 5 to the power 5 3 cube 2 square, it is less than or equals to 1. 1 to the power 11 is also 1. Now take it to the right side. You get A to the power 5 B cube C square D less than equals to 5 to the power 5 3 cube 2 square. This is going to be your answer. And a very good example of AMGM. Understood? Have a look. Anybody having any doubt may raise your hand. All right. So now we will do some miscellaneous type of series. All right. Like 1 upon 2, 3, 4, 1 upon 3, 4, 5, 1 upon 4, 5, 6, and so on is k by 101. Then they are asking for 34k is equals to. Now see, first of all, I have to start with the kth, say nth, some rth terms. Rth term of the series. Now the art here is how to find the rth term. Got it? How to find the rth term? See, See at the first term of every term, 2, 3, 4, next 5, up to 100. So what will be the rth term of 1, 2, 3, 4, 5, up to 2. What will be rth term? Rth term will be in this case r plus 1. Got it? So it is first term will be r plus 1. Now next is what? See, one more than this, one more than this, one more than this. So in this also r plus 2. Next is one more than this, one more than this. Then this is r plus 3. Got it? Now this is in the denominator r plus 1, r plus 2, r plus 3. Now see their difference, create their difference in the numerator. So it will become r plus 3 minus r plus 1. Difference of what? Difference of last minus first of the denominator. Again I repeat, difference of last minus first of the denominator created in the numerator. With this, you have created 2 extra in the numerator. So divide by 2 also. So it is 1 by 2 times 1 upon r plus 1 r plus 2 minus 1 upon r plus 2 r plus 3. Got it? Now this is your TR. This is your TR. Now what will be T1? T1 is what? Half of 1 upon 1, 2, 3 minus 1 upon 3, 4. T2 is half of 1 upon 3, 4 minus 1 upon 4, 5. T3 is half of 1 upon 4, 5 minus 1 upon 5, 6. And so on. See, we are going up to which term? We are going up to this will be what? 99th term. Because you are starting with 2. Got it? So T99 will be half of 1 upon 100 into 101 minus 1 upon 101 into 102. Got it? Now you add all of them. If I add all of them, this will cancel in this manner. So we will be left with only 2 terms. One is this, other is this. So what will be the sum? Sum will be half of 1 by 6 minus 1 upon 101 into 102. Understood? Now they are asking for 34K. Let's see. So we got this. Now, the series is K upon 101 they are saying means S upon 101. Let us say they are calling it, this total sum they are calling as K upon 101. So what will be your K? In that case, your K will be 101 upon 12 minus 1 upon 102 into 2. Understood? Now they are asking for 37 also. So 37K will be 101 into 37 by 12 minus 37 upon 2 into 102. Yes. 34. Sorry. 34K. They are asking for 34K. So make it 34. 34. 34. 4 3 are 12. This is 34 3. So it is 101 into 34 upon 12. Here minus 1 upon 6. Here if I cancel by 2, 101 into 17 by 6 minus 1 by 6. Now you can calculate and simplify. Understood? So this is it. Have a look. Got it? Now, see this series. Another example of miscellaneous series. Sum of 10 terms of this series. So I give you an overall idea how these kind of series we simplify. Got it? Say the nth term of the series, first of all, that is, see, numerator is 1, 2, 3, 4, so n upon 1 plus n square plus n to the power 4. N upon 1 plus n square plus n to the power 4. Now, how do I simplify? First of all, remember one more thing about the nth term. Once you get the nth term, don't just believe that you are correct. So do one special activity, just check the values for n as 1, 2, 3 and check if you are getting first, second and third term. Because if you are not getting first, second and third term, means there is a mistake. Getting my point? So whenever you are writing the nth term after like assuming or simplifying for the nth term, always check for n as 1, 2, 3. Are you getting first, second and third terms? Now it is n upon n to the power 4 plus n square plus 1. Now add n square and subtract n square. So that is n upon, see these three terms. Isn't it n square plus 1 whole square minus n square? N upon n square plus 1 whole square minus n square. So it is n upon. This is a square minus b square. So that would be a minus b into a plus b. So n square minus n plus 1 into n square plus n plus 1. This is your nth term. Understood? Now, let's do one thing. In the denominator, you have n square minus n plus 1, n square plus n plus 1. Create their difference. Their difference is n square plus n plus 1 minus n square minus n plus 1. With this, now numerator is having 2n. N was already there, means 2 extra appeared, so divide by 2 also. Got it? Divide by 2 also. So with this, you got half of 1 upon n square minus n plus 1 minus 1 upon n square plus n plus 1. Got it? Now, what is T1? T1 is half of 1 by 1 minus 1 by 3. T2 is half of 4 and 1, 5 minus 1. 4 plus 1, 5 minus 2, 3. 1 by 3 minus 1 by 7. T3 is what? Half of 1 by 7 minus 1 by 13. And so on. T10, they're asking for 10 terms. T10 will be half of 1 by, now see 100, 101 minus 1, 91 minus 1 upon 100 and 101 plus 1 plus 10 is 111. Now again, if I add all of them, you see they are cancelled. So you are left with just two terms, this one and this one. Got it? So sum of these 10 terms is half of 1 minus 1 upon 111. So that is half of 110 upon 111. So it is 55 upon 111. This is your sum. 55 upon 111. What they were asking? That is 55 upon 111. B is the correct answer. Have a look. Good question, good approach. And this factorization which I have done, n to the power 4 plus n square plus 1, it's not easy to clock. Understood, everybody? Any doubt, anyone? All right. Now, let's try this one. See, this is quite a different question. I give you like 2 minutes to think over it. 5, 11, 19, 29, 41. Do it. Yes, quickly. So if you got any answer, mark your answer in the poll section. Yes, please. Somebody marked Bombay. Let's see. Calcutta, one also marked Calcutta. C option. Others also. Quickly do. All right, now let's do it. Sum of the series first 20 terms. See, the series is 5 plus 11 plus 19 plus 29 plus 41 and so on. Now there will be an n minus 1 term. Then there will be an nth term. If you realize, difference between these two terms is 6, 8, 10, 12 and so on. That means difference of terms are in AP. Yes or no? So I do one thing. I write the same series again, pushing by one term. So 5 comes here, then comes 11, then 19, then 29. Here it will come Tn minus 1. Here it will come Tn. I did nothing. I wrote the same series once again. All right. So now let's create their difference. Minus, 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 minus. Subtract these two series. See, 0 is here. Now see carefully. 5, then there comes 6, 8, 10, 12, up to this term, up to this point. Difference will be here. There will be some term, I don't know. There will be some term and minus T. Got it? Now you bring this Tn to the left side. So Tn is C5. Except see, from here to here, there are total n terms. But 5 is not contributing to the AP. So I do not count this AP. So from here to here, this is what? AP of n minus 1 terms. Yes or no? So it is 5 plus, take 5 common. Well, 5 already is here. Then Tn is n minus 1 by 2, 2a, 6 to the 12, plus n minus 2 into d is 2. Correct? So it is 5 plus, it will be n minus 1, 6 plus n minus 2. So 5 plus n minus 1, n plus 4. So n minus 1 into n plus 4. So it will be n square minus plus 3n plus 1. But again, I told you, don't just believe exactly on what you have done. Getting my point? So don't directly just believe what you have done. You need to check also once that the term you have calculated, if it is correct or not. See, in this term, if I put n as 1, what I'm getting? 5, correct? N as 2, so 4 plus 6, 10 and 1, 11, correct? N as 3, if I place 9, 9, 18 and 1, 19, correct? So 3 terms are okay. That means we have done good job and we got our n term. So that means your Tn is n square plus 3n plus 1. They are asking for sum of first 20 terms. So sum of 20 terms is sigma n varies from 1 to 20 Tn. That is sigma n varies from 1 to 20 n square plus 3n plus 1. Now it is sigma n square plus thrice sigma n plus sigma 1. N varying from 1 to 20, n varying from 1 to 20, n varying from 1 to 20. Now sigma n square formula, I have told you, the formula is n plus 1 to n plus 1 upon 6. So it will be 20, 21, 41 upon 6. Thrice of sigma n is n into n plus 1 upon 2. So 20 into 21 upon 2 and plus 1, 20 times. This is 20. Now you add all of them, you will get your correct answer. Understood? Am I correct? Have a look. Note it down if you are trying to. Right? Have a look. Now, see this question. This one. 1 cube plus 2 cube plus 3 cube up to nth term. 1, 3, 2, 5, 3, 7 up to 2 nth term. All right. Now see. Numerator is directly sigma n cube. But what is denominator? Denominator pe take a look. First one, then two, then three. So in nth it will be n. Then 3, 5, 7. What is the nth term for 3 plus 5 plus 7? That will be 2n plus 1. So it is n into 2n plus 1. This is given as 9 by 5. They are asking you to find the value of n. All right. So you take a minute. If you get the correct answer, mark in your answer in the chat box. Quickly. Very easy question. Go for it quickly. Give it a try. Now see, anybody see sigma n cube upon it will be sigma 2 sigma n square plus sigma n. They are providing you it as 9 by 5. Now sigma n cube formula I told you in the first lecture, n plus 1 by 2 whole square divided by 2 times sigma n square is n plus 1 2n plus 1 upon 6 plus n into n plus 1 by 2 is 9 upon 5. Now if you realize this n into n plus 1 by 2 cancel, n into n plus 1 by 2 cancel, n into n plus 1 by 2 cancel. So what I'm left with n into n plus 1 upon 2 whole divided by 4n plus 2 by 3 plus 1. This is given as n by 5. Sorry, 9 by 5. 9 by 5, correct? Now it is n into n plus 1 upon 2. Here it will be 4n plus 5, numerator may it goes 3, is 9 by 5. Now it is 3 3 ja. So 5n square plus 5n is 24n plus 30. So it goes 5n square minus 19 and minus 30 equals to 0. This is 35 ja 150. 5 into 30, that is 25 into 6 also. So factors are 25 and 6. So it is 5n square minus 25n plus 6n minus 30 equal to 0. 5n common and minus 5 plus 6 common and minus 5 equal to 0. So 5n plus 6 into n minus 5 goes 0. So now this cannot be 0. That means n equals to 5. Understood? Have a look. Got it? Now the next page we have only simplification, nothing much. Now let's come to another very good question. If the sum of the series 1 by 2 minus 1 by 3, 1 by 2 square minus 1 upon 2 into 3 plus 1 by 3 square, 1 upon 2 cube minus and so on so forth. Don't you realize if I take 1 by 2 as alpha and 1 by 3 as beta, I don't have to write it again and again. So it is alpha minus beta plus alpha square minus alpha beta plus beta square, alpha cube minus alpha square beta plus alpha beta square minus beta cube plus alpha to the power 4 minus alpha cube beta plus alpha square minus alpha beta cube plus beta to the power 4 and so on so forth. Got it? Now see, if I multiply this term by alpha plus beta, what do I get? I get alpha square minus beta square. Yes or no? If I multiply this term by alpha plus beta, I get alpha cube minus beta cube. If I multiply this term by alpha plus beta, what do I get? See, once we do it, we will be sure. Alpha to the power 4 minus alpha cube beta plus alpha square beta square minus alpha beta cube plus beta alpha cube minus beta square alpha square plus alpha beta cube minus beta to the power 4. Now, if you see, they are cancelled, they are cancelled, they are cancelled. So you are left with alpha to the power 4 minus beta to the power 4. That means this will keep on going in this fashion. Means if I multiply this term by alpha plus beta, I will get alpha to the power 5 minus beta to the power 5. That means now if I multiply this entire series by alpha plus beta, I will have to divide by alpha plus beta also. And what do I get? Alpha square plus alpha cube plus alpha to the power 4 and so on, minus beta square plus beta cube plus beta to the power 4 and so on. So it is 1 upon alpha plus beta. Sum of this infinite GP. See, alpha and beta both are less than 1. So sum of this infinite GP is alpha square upon 1 minus alpha. This will be beta square upon 1 minus beta. Got it? So it is 1 upon alpha plus beta. It is 1 minus alpha, 1 minus beta. Alpha square minus alpha square beta minus beta square plus alpha beta square. Now this is 1 upon alpha plus beta. If I see here, this is what? Alpha square minus beta square. Yes. And with a negative sign, if I take alpha beta common, I get alpha minus beta upon 1 minus alpha, 1 minus beta. Now we are done. Take alpha minus beta common. In the numerator, you get alpha plus beta minus alpha beta upon alpha plus beta, 1 minus alpha, 1 minus beta. Understood? Now you have the values of alpha and beta as 1 by 2, 1 by 3. Put these values, get your answer. Nice question. Have a look. And now see, these kind of questions, they do not come into any series. The kind of question we are doing today, like this one, and this one, this one, there's no name for this series. These are just like normal questions, so with a different approach. Understood? So just multiplying by alpha plus beta is creating the magic here. Now, come to this question. A is given to you, B is given to you, then they are asking for A upon B is what? Now, this is a question which scares almost every student. And it is actually scary. It is written in such a tough manner that you get shocked. How do I get it? But see, the approach for these kind of question is, first of all, at least write 3 or 4 terms. Like if I write series A is what? If I write series A, put n as 1. N as 1 means 3 minus 1, 2. So 1 by 2. Then put n as 2. 2 will be 3 plus 1, 4, 4 square. Then put n as 3. 3 is what? 3 minus 1, 2, 2 cube. N as 4. So 4 if you place, 4 will be 3 plus 1, 4 to the power 4. So in the denominator, terms will be either 2 to the power something or 4 to the power something, and so on so forth. Now you can see this is divided into two parts, 1 by 2 plus 1 by 2 cube plus 1 upon 2 to the power 5 and so on, plus 1 by 4 square, 1 upon 4 to the power 4, 1 upon 4 to the power 6 and so on. Got it? So it is A upon 1 minus R. R is 1 by 4. A upon 1 minus 1 by 16. Common ratio will be, yes, 1 by 4 square, which is 1 by 16. So it will be 2 by 3 plus it will be 1 by 15. So it will be 11 upon 50. And see, I'm getting 11 somewhere. So this may be the correct. Got it? Now let's go with B. Now see what is happening with B. Everything is fine. This extra K. So series is completely same. But now the signs will be alternate. So for n as 1, what do you get? Minus 1 by 2. For n as 2, what do you get? 1 by 4 square. Minus 1 by 2 cube. 1 by 4 to the power 4. Minus 1 upon 2 to the power 5. 1 upon 4 to the power 6 and so on. Now series is going with alternate plus minus sign. So now negative common. 1 by 2 plus 1 by 2 cube plus 1 by 2 to the power 5 and so on, plus 1 by 4 square, 1 upon 4 to the power 4, 1 upon 4 to the power 6 and so on. Got it? So now it is A upon, same answer, I'm going to write it again. So it is minus 2 by 3 and plus 1 by 15. So this time it will come minus 9 upon 15. This is your B, this is your A. So your A by B will be minus 11 upon 9. Very good question. A by B is minus 11 upon 9. Understood? Now, see this question. Let for n equals to 1, 2, 3 up to 50, Sn be the sum of infinite geometric progression whose first term is n square and whose common ratio is 1 upon n plus 1 whole square. Then the value of something they are asking. First of all, write Sn. Sn is an infinite GP with first term as n square. So formula is A upon 1 minus R. So n square upon 1 minus 1 upon n plus 1 whole square. Yes or no? So Sn is n square into n plus 1 whole square divided by n plus 1 whole square minus 1. So it is n square n plus 1 whole square upon n plus 2 into n. So your 1 n cancels. So it is n into n plus 1 whole square upon n plus 2. Got it? Now, my next duty is to simplify this expression. So it is Sn plus 2 upon n plus 1 minus n plus 1. That is Sn plus, if I take LCM here, n plus 1 whole square, I'll get 2 minus, sorry, just simply n plus 1. So I'll get 2 minus n plus 1 whole square. Correct? So Sn plus, it will be minus n square minus 2n plus 1 upon n plus 1. Correct? Now put Sn, that is n into n plus 1 whole square upon n plus 2 minus n into plus minus n square minus 2n plus 1 divided by n plus 1. Got it? Now if I take LCM, n plus 1, n plus 2, you will get n times n plus 1 whole cube plus n plus 2 into minus n square minus 2n plus 1. Let me see if I'm going correct or there is. Sn is a upon 1 minus r. So a square upon 1 minus 1 upon n plus 1 whole square. If you take LCM in the denominator, n square n plus 1 whole square, you get n plus 1 whole square minus 1, which is a plus b, a minus b. So n, 1 n cancels. So it is n into n plus 1 whole square upon n plus 2. Everything is fine. So let's do one thing. Let us not calculate everything right away. That's fine also. Let's go with it. 2 upon n plus 1 minus of n plus 1. So if I take LCM here, which is already taken, n plus 1, n plus 2. This is n to the power 4, 3n cube, 3n square plus n minus n cube minus 2n square plus n minus 2n square minus 4n plus 2. So it will be n to the power 4 plus 2n cube, 2n square minus n square, 2n minus 4n minus 2n plus 2. This is what I got. Divided by n plus 1, n plus 2. This is n to the power 4 n equals to minus 1 is a root. There is a role of 1 by 26 also. Sigma Sn plus 1 by plus 2 upon n plus 1 minus of n plus 1. The role is of calculation only. It is n into n plus 1 whole square upon n plus 2 divided by 2 upon n plus 1 minus of n plus 1 upon n plus 1 and into n plus 1 square upon n plus 2 minus n square minus 2 n plus 1 upon n plus 1. Maybe this is also correct. Now if I'm supposed to factorize it, minus 2 is a root, minus 4, no, minus 1 is a root, it will be 1, minus 2, minus 1, First check for 1. 1 minus 2 minus 1 plus 2 plus 2. 4 and plus 2. How do I go away with this? 2 over n plus 1. Okay, no problem. We'll start next class from this question only. So in this session, what we have covered few very good questions from JEE Mains. This question is also something like I might be mistaken or there is some printing error in the question. We'll get over with this in the next lecture. So till then, I hope you enjoyed this session and we'll catch up next week. All right, that is all for the day. Thank you so much.